Good morning, guys. Okay, last class we are trying to understand tree set. Okay, look at here. This is our operating system. We have drives. Inside drive, I have folder. Inside folder, let me choose one folder, any folder, let me open. Okay, in this folder, okay, I'll do one thing. Some folder I am opening. Say reflection. Tell me. Here I have files. These files, there is an option called what? Sort. Right? There is an option called sort. Then here I am trying to use more. Okay. Okay. Right click. Whenever I create these files in this folder, whenever I create these files, and when I write like this, what happened? They are changed, arranged, sorted according to name. Right? Now tell me. Right click, new. I am creating one file with the name a.java. Already there is a file with the name a.java. Again a.java, allowed or not allowed? Not allowed. If you try to throwing error, if you change a file name extension, the file name, yes. And do you want to rename newtext.me 8 of 2.j? There is already a file with the name in this location. So that means, tell me, can I consider this folder as a collection or not? And inside this collection, I have all these files. Okay. And in this file, duplicates are accepting or not accepting? Not accept. Then what is this collection set? Okay. And here inside the set, all these files are arranged based on the name wise ascending or not? Then is it a seta, sorted seta? Sorted set. Okay. The files are saving in the one particular order, name wise ascending order, or size wise ascending order, or type wise ascending order, or date wise ascending order. So what is this? Sorted set. Sorted set implementation is nothing but what? Tree set. So tell me, in your hard disk, inside a drive, a folder when you create, this folder is nothing but what? Tree set. Point is clearer? Right. This is a practical example for you. Okay. Next, tell me, here the files presently by default, understand, whenever I create a folder and save the files in that folder, by default, the files are stored in which order? Name-wise ascending order, right? By default, they store name-wise ascending order. Now tell me, is it possible to store name-wise descending order? Is it possible for me to store name-wise descending order? Yes. Can I store other property-wise ascending and descending order? Yes. Observe now, this is a file. Can I consider this file as an object or not? Yes. This object contain how many properties? Name is there, size is there, date is there, type is there. Okay, these are all what? Properties of this file object. This file has a name, this file has a size, this file has a date, this file has a type. Now, these all considered as the values or properties of this object. Now, based on these values, based on these properties, I want to sort this object. Then tell me, if we want to sort these objects based on the type, what should I do? I have to ask this operating system, now please save name-wise ascending order, name-wise descending order. Save size-wise ascending order, size-wise descending order. Save date-wise ascending order, date-wise descending order. Save type-wise ascending order, type-wise descending order. Okay, na? For that, there is an option. Right click, sorted by. Observe, for presently it is there in name and what ascending order. I want name, descending order. Look at that, descending order changed or not? Right? Right click. Now sorted by. Observe now, I am choosing date modified. So files are changed based on date modified order. Right click, sorted by date wise ascending order. Look at that ascending order coming or not? So tell me now, I want you participate and try to use your brain and tell me. A object, okay, a class, objects are storing inside a collection. Inside a collection, I can store these objects in a sorting order. Sorting order means what? Ascending on or what? Descending on one property. On one property value comparison. Okay, clear? Then, now my question. There are two sorting algorithms. Number one, name-wise ascending order. Another sorting order is what? Name-wise descending order or other property-wise descending order. So, a object can contain multiple sorting algorithms. Can I provide those many multiple sorting algorithms in a single class? No. Sorting algorithm means what I told you last class. It has two algorithms. Number one, comparison algorithm. Number two, swapping algorithm. Number two, swapping algorithm. What is the meaning of comparison? First, collection object you created. And then, first what you stored? A. Then, what you are trying to store? C. C is compared with the existing object. If found greater, stored which side? Left side. Okay. Then I'm storing B. Then B is compared with what? Okay. B is what? Now B is what? It will compare with A. Okay. Compared with A. And then now this A is, B is compared with A. A minus A. Sorry, B minus A returns true or false? Sorry, returns positive number or negative number? B minus A returns positive or negative? Positive. Positive means which side should store? Right side. Right side already one object available, na? Then what it will do? Again it compare. B minus C returns positive or negative? Negative. B minus C returns negative. Then negative means left side. Left side means this position of C has to move to right. And here B should be stored. Yes or no? This is called sorting. So sorting algorithm has how many internal algorithms? Two. Number one, comparing. Number two, swapping. Comparing and swapping. Let's see now. I'll show you this point practically here. This operating system already contains the comparison and swapping algorithm. Observe. Control Shift N. Okay. Here I am trying to give some name called A. Okay. When I press enter, tell me this folder name is compared with the folders available in this hard disk, na? I mean in this folder, and then found its position and arranged like that. Observe. Right click, sort by name. Okay, look at that. Where it is going now? It is coming here. Why it is coming here? Let me again show you. Delete this folder. Now, Control Shift N. Control Shift N. A. When I press enter, it will look at there. Where it is going? Beginning. That means all these files are moving to the right side na. That means what happens? Swapping na. Swapping anything but adjusting. Moving this location to next location, this location, that is called what? Swapping. How it is coming here? When you create this A, it is comparing with this folder, found it is what? Smaller. And then A minus P, negative na? A minus P is negative. Negative means what? Left side. Then it is moving all these files one location right and making this first location empty, and it is adjusted here. So this is how the swapping will be working background. Okay. What is the sorting algorithm? Sorting algorithm contains how many algorithms? 2 algorithms. Okay. Number 1, comparing. Number 2, swap. Okay. In comparing, what it will do? It returns either negative or positive or 0. If written negative, swapping algorithm. If written negative, stored left. If written positive, stored right. Return 0, not stored. Samajh mein aaya? Everyone understood? Now I have a question. Tell me now. This sorting, either comparing or swapping, do you have only one sorting order or multiple sorting orders? Multiple sorting orders. Multiple sorting orders. Then this sorting comparison logic is given by JVM, given by adding object class developer, adding object class developer. If I am trying to store student class internally, we must have comparison logic. Because how JVM knows you want to compare students on which property? You want to sort student objects on student number wise, student name wise, how it knows? Are you following? So what is important point? The student objects are compared. One object is compared with another object on which property? There are so many variables inside. Student number, student name, course fee, height, weight, email, mobile. So many are there. On which property you wanted to compare is specified by whom? The same student class developer. How the student class developer write the comparison logic? Just we have to define one method. Listen carefully. This method signature or the method prototype must be student class own decision, because this logic should be executed by whom? When I call ts.add up, one object I am adding, let's say student object S1. Tell me student object directly stored. Then when I write ts.add up S2, tell me S2 must be compared with S1 and take decision should store S2 left side or right side or not store. For that, compulsory S2 comparing with S2 by whom? S2 comparing with S1 by whom? Add method. Add method should call the logic available in student class. Then the method signature must be student class own decision or must be tree set class applied method. Think. Come on, fast. Reset class must give that method signature or student class developer should take decision. Who is calling method? Reset. Then the method signature should be known to whom? Come on, think. Who is calling method? Then the method should be known to whom? Treeset. Treeset should know that method. Next, treeset class is given which version? 1.2. Student class is coming when? Now 2025 version. Yes or no? How treeset class developed 1.2 version? Knows. Because you want to treeset class add method internally call that method. Na? That means this method must be already available in 1.2 version only. Na? So tell me, the method that you want to call inside add method must be provided by whom? Treeset class developer. Treeset class developer must provide the method and the same method should be implemented by student class. Everyone understand? Repeat once again. Very, very important point. For comparing one object with another object, here we required comparison logic. Who knows this comparison logic? Reset class developer, student class developer. student class developer. How student object compare with another student object? Logic is known to only student class developer. Then where that logic should be right? Inside student class. Okay. Now the method name, method signature means prototype, parameter, accessibility modifier, execution level modifier, return type, method name, parameters list, throws, exception. This entire details prototype must be provided by whom? Treeset class developer, student class developer, treeset class developer, because he is calling the method. Prototype must be provided by the treeset class developer and its implementation must be provided by student class developer. Understood? Then my question is, where that method prototype is provided? In the class treeset. Okay, inside class treeset, the method prototype is available. Then the class student extends from treeset class, override that method. Is it right or wrong? Wrong. Why? If your class is extending from treeset class, then the student class become collection class na? You want your class as a collection? No. You want collection behavior? No. I don't want collection behavior. I want only sorting behavior. I want only sorting behavior. Then providing this method inside treeset class is a wrong approach. What they did, they have provided one separate interface. Tell me, overriding or implementing the sorting logic method is optional or mandatory? Mandatory. If you want to store your object to the treeset, inside treeset class, if the methods are, if the logic is not available, can this object can be sorted or not sorted? Cannot be sorted. So if you want to store your student class object inside the treeset, compulsory sorting logic must be there. The sorting logic to provide compulsory treeset provided method must be there. For that, how can Java force one class to implement one method? By using which concept? Interface. Interface, what is the name of the interface? Comparable. What is the interface name? Comparable, comparable, comparable. Because it is meant for comparing, na? Comparable of, the method is what? Public, return type is int, method name is compared to of object, object O, semicolon. So what is the interface available to provide comparison logic? Comparable. Then first step, what Sun Microsystem did, they declare the interface called comparable with the method compared. Second, they created class student. Inside class student, they define a class called what? Treeset. Inside class treeset, what is the method available? Public void add of, not void, boolean. Add of, what is the parameter coming? Object obj, open bracket. Inside, what is the logic available? Simply, they need to compare the given argument object obj with the object already available in the collection, with the already objects available in the collection. For that, what is the method calling? Compare to of already available elements. Okay. Then what is the logic? If less than, if comparative method returns what? Integer number, na? If it returns less than 0, then store obj left side of element. Else, if obj compare to of, okay, compare to of element is greater than 0, then store what? Right side. Are you following? Then next, else, if it returns 0, don't store and returns what? False. Okay, clear my point? So tell me, what is the add method internal logic in treeset class? First step, what happened? They provided interface. What is the interface name? Comparable. Comparable of T. Comparable of T. T stands for what? Type. Which type of object you want to compare? Then public return type in. Method name is what? Compare to of TT. Which type of object you pass, the type of object will be compared. So this is the interface available. Then Sun Microsystem created a class called what? Treeset. Treeset of E. E stands for element. The element you are adding. Then inside, okay, public return type is boolean. Method name is what? Add of. Inside add method, what is taking? Element E. Now tell me, very, very important. Using this E, int position equal to E dot compare to of element. Can we call compare to method by using element? Possible or not possible? What is E type? E. What is E? The past object. What is the past object? Object. So compiler software search for this comparative method in which class? Object class. In object class, comparative method available or not available? Not available. Where it is available? In a comparable interface. So what is the most important point? Whenever you call add method in the tree set, the first statement is comparable. The given object is typecast to whom now? Comparable of E. The given object is typecast to comparable of E. Then int position equal to comparable dot what is called compare to of what you pass now? Element. Okay. Then if condition, if position less than 0, if position less than 0, open bracket, here store which side? Obj or E stores left side of element. Okay. Else bracket, else if position greater than 0, then what happen? E stores right side of what? Element. Next element, else then what? Don't store. Okay, don't store. That's it. So this is the program available inside TreeSet. So now with this knowledge, you must clearly get some idea on how TreeSet internally working. So TreeSet internally using which interface? Comparable. For what purpose? Comparing the past object with given object. Okay, sorry. Comparing given object with objects available in the collection. Is it clear? Then tell me. Now I have a class called, everyone should answer, student. Now tell me, can I store any class object to the tree set? No. Now I created tree set object tree set ts equal to new tree set of. Then if I call ts dot add of student object s1, assume that I created student object. Then s1 object is passed as argument to add method. Okay. Then in what is the object available in E1? S1. Then S1 is trying to convert typecasting to what? Comparable. Now tell me, is it possible or not possible? If you want to typecast one object to comparable, it must implement from comparable interface now. Now tell me, what is the rule in storing a object inside tree set? It must be implementing comparable interface. Do you remember what do you call multi-threading chapter? In multi-threading, how much topic we completed? Daemon thread I explained, types of threads explained, yield method explained, yield sleep method explained. Types of threads completed. Types of threads, daemon thread, non-daemon thread. After that, controlling threads execution, yield method, sleep method, join method I didn't explain, but yield and sleep method I explained, I remember. Sleep, join not explained, yield not explained. Okay. Everyone listen. Multi-threading topic I want to take. Okay. The topic remaining is what? Are you free at 6 p.m. for today and tomorrow? 6 p.m. 6 to 7:30 p.m. No? Spring Boot class. Okay. Okay, okay. Tomorrow? Tomorrow no class? Okay. So what I will do, today 6 p.m. to 7:30 p.m. Tomorrow, I'll inform in the Google Classroom, okay? I'll do one thing. I'll inform in the Google Classroom. So this topic, yield method, sleep method, join method, synchronized block, and wait methods. That is called, this is synchronization and this is inter-thread communication. Okay, these topics are pending in multi-threading chapter. These topics I will share, yield and sleep method video I will share today. Okay, now only I will share after class. By evening you complete it. Okay, now you have already joined Spring Boot, you go to Spring Boot class. Okay, so join method. Which class is not there? Up to daemon thread available, na? Material uploaded, no? Multi-threading. Yesterday club. You are asking about collection. Rajat Raj. I am talking multi-threading, no? What, man? Why you are confusing me? Yesterday material not uploaded because the topic was not completed. Okay, na? Listen. So yield and sleep method, this topic, and types of thread, daemon thread topic and yield sleep method. Yesterday I covered that video. I will share. Please try to listen as a revision topic. Okay, na? Join and introduction to synchronization. These two topics. Today night, after you go, by the time you reach your class hostel room, it will be available. It's a small budget topic. Please try to check. You will understand. First you complete this so that it will be revision. Then this topic will be understand. Okay, na? Next. So this inter-thread communication, if at all synchronized little, maybe it will be covered here. Then last topic is inter-thread communication wait. So tomorrow I want to take this session at 11 a.m. Simple topic. Okay, 11 a.m. to 1 p.m. Okay, 11 a.m. to 1 p.m. Just I want to take this topic. So people who are interested can join at 11 a.m. I'll share the link. Understood? This is the multi-threading topic. This video also I will share. If you cannot attend 11 a.m., ignore. I'll share that 3 videos, 1, 2, 3. You people can check via Google Classroom. Okay, now? So with this, we completed our multi-threading. Okay. Now tell me, in multi-threading chapter, if you want to give the logic to execute in custom thread, if you want to give logic to the custom thread, can I give any class as an argument to the thread class constructor? No. Which type of object only I can give as an argument? Runnable. Remember or forgot? Runnable. Only runnable type object we can give as a argument. If you try to pass other type of object, compiler will throw error. Tell me, in a tree set class, okay, next. Let me take object output stream dot write object method. Remember, write object stream or write object, any object I can give as an argument. No compile time error, but we will get runtime error, not serializable exception. Remember, similarly, like runnable and serializable, we have one interface called what? Comparable. So if your class is not implementing from comparable, can I store that object to the tree set? No. If you try to store, compile time error or runtime error? Runtime error. What the runtime error? Class cast exception. Because tree set internally uses number 1, comparison logic, number 2, swapping logic. Comparison logic is for checking the current object position either less than, greater than, or equal. Based on that, swapping will be. Who is responsible for providing comparison logic? Comparison logic is responsible to provide by the adding object class developer. Who is providing the swapping logic? Swapping logic will be provided by Sun Microsystem in TreeSet class. As a developer, what you have to do? The class whose object you want to store in TreeSet for sorting, that class must implement comparable interface. Else we will get what? Class cast exception. Everyone understand? Right. Then tell me, inside, okay, now this student class implementing comparable interface and implementing comparative method. Implementing comparative method. Then my question, what is the logic I can write in comparative method? One sorting logic. Okay, for example, I want to sort the students based on student number. Okay, student number I want to sort. I given logic student number sort. According to student number, the objects are sorted. But I want to sort my students on course wise. I want to sort the students on height wise. I want the students on weight wise. Then now tell me, if you want to sort the students based on different property, I have to write the logic in this comparative method. Na? How many logics I can write in comparative method? One logic. Every time if you want to change the sorting logic, every time I have to go there and modify the logic. Na? Is it okay? Na? Not okay? Na? Not okay. Tell me, by default, your parents has provided one name to you in your childhood, isn't it? That name is the default name. When you join the school, once you become friends, once you get the friend, in your friend circle, one new name is coming to you. Na? Then you are moving from this circle not liking and move to another circle, another group of people. They also created one more new name. Na? Now school days completed, come to the college. College friends, again another name. What is the default name? One name is there. But people are keep on changing that default name to another name, another name. That means in a tree set object, by default objects are stored in the tree set based on the comparative logic, based on the logic given in the comparative method. So comparable interface is meant for providing what logic? Default sorting order logic. Default sorting order, you decide one. Then that logic we write. By default, it follows that. Then you are either same class developer or other class, user class developer. I am using student. I am the college developer. I am using student. Students are by default sorting by student number. But I am the PT master. Okay. Now students are coming into playground. In the playground, I will ask the students stand in a line by student number or height wise. That means I am asking change your order. Right? Now, I am the competition master where more food is provided, food competition we are sending. Then we will sort the students based on what? Who can eat more food. More to less, descending order. More food eating people should be first. Right? A competition to win. And more to less, descending order I have to store. Then tell me, place to place, the students order changing or not? Now there is a quiz competition is going on. Quiz competition going on based on student number wise, based on the intelligence wise. Intelligence descending order, ascending order. Ascending order. Less intelligence to high intelligence or high to less? High to less. Then this intelligence descending order I wanted to store. So finally tell me, one object has how many sorting orders? Many. Among them, you make one sorting as a default. Remaining you make as what? Custom sorting order. What a custom sorting order. To supply this custom sorting order logic, we have another interface called comparator. What the interface name? Comparator, with a method called compare. What is the method name? Compare. Now tell me, there are two interfaces are there to supply sorting logic. The first interface is interface comparable. Interface comparable T open bracket. Inside what is there? Public. Return type is int. Method name is what? Compare to of. Parameter is TT. Semicolon. Okay. Next interface comparator of T. Okay. Open bracket. Inside public. Return type is int. Method name is what? Compare of. Tell me. Here carefully observe. Compare to method is available in student class, na? Student class implement comparable interface and it contain what? Comparative method. Comparator is implementing by student class, other class, other class. You want to provide custom. Custom means what? Which is not part of the student class. It is in another class. Then from another class, how can we pass objects? Only as arguments. T1, T2. Observe now. What is the difference between comparative method and compare method? Comparative method has one parameter. Comparative method, sorry, compare method has one parameter. Comparative method has one parameter. Compare has what? Two parameters. Why? Comparative method is called by using adding object by passing already available object. Because comparative method is available in the same adding object class. One object is coming as a current object, another object is coming as a argument object. Whereas compare method is available in another class, not adding class. So I can call it as student comparator. The class name is what? Student comparator dot compare of. You are passing two student object S2 comma S1. समझ में आया? The calling style is different. This compare method not available in the student class. It is available in another class. Hence, the both student 1 and student 2 of different class must be passed as an argument. Whereas in compare to first object is current object student, second object is argument object. So comparative method is having one parameter, compare is having two parameters. This is one of the important entry question. Why comparative has one parameter, compare has two parameters? Comparative method is available in the adding object class. It is called by using adding object by passing preset object as a element, preset element as an argument. Compare method is available in a different class, not in adding object class. Hence, the adding object and already available object in preset must be passed both as a argument. Hence, it is okay. Then now tree set class. Now tree set class internally using how many objects? Two objects, two interfaces. Interface tree set. Here there is a private comparator CMPR semicolon. Here there is a constructor tree set, no param constructor. Here I have another constructor tree set of comparator CMPR open bracket. Inside we have the logic. This dot CMPR equal to CMPR. Everyone try to answer. Bolo. Is this collection chapter, non-static member chapter? Non-static member chapter with the collection terminology. I created tree set TS1 equal to new tree set. TS1 dot add of S1, TS dot add of S2. Everybody trying to use your brain or sleeping? S3. Tell me now. Here, student objects are compared by using compare to method or compare method? Come on. Compare to na. Compare to S2 dot compare to of S1. S3 dot compare to of S1 and S3 dot compare to of S2. Why it is comparing? Because you didn't mention comparator na. By default comparison will be used, isn't it? When you are adding object, tree set by default use what? Default comparison, which is supplied by a student object. Because you didn't mention any comparator here. Everyone tell me. TS2 equal to new tree set of, I am passing student comparator. Okay, very student comparator. I will write the code further separately. TS2 dot add of same objects I am storing S1, TS2 dot add of S2 and TS2 dot add of S3. Bolo. Now what is compared now? S2 object is compared with compare to na comparator. Now student comparator dot what method is called? Compare of by passing what? S2 comma S. Everyone understand about it? Tell me, if you mention comparator, means you want your own custom sorting order, then tree set follows your order. If you don't mention any comparator here, then it uses what? Default sorting order. Default sorting order. So what is the important point? Okay, tree set internally uses either comparator or what? Comparator or comparable. By default, what it will be used? Comparable. Now, if you specify explicitly, then it uses comparator. Now tell me final conclusion. What is comparable and what is comparator? Comparable is a interface that is used for providing default sorting order to the tree set. Comparator is also interface. It is used for passing custom sorting order to the tree set. Tree set by default uses comparable. Tree set uses comparator only when we pass explicitly as a argument. Comparable contain only one method, that is compared to, which will take one parameter. Comparator also contain one method which is compare, which will take two parameters. Comparable available in java.lang package. Comparator available in java.util package. Why it is available in java.lang? Because it must be available it must be available for multiple classes in the project now, because it has to implement. For avoiding importing util package, they have given in which package? Java.lang. Okay, na? Right. And the comparator only specifically for collection class implementation. That's why they have given with what? In what? Java.util package. So this entire theory knowledge, let us summarize. You got some idea. Let us summarize this theory point, and then we'll go for I want you read these points so that when I'm writing program, you will easily understand. Tree set points, tree set internals. Okay, I'll come back to this first. Read these points yourself. All our 12 points. Remember 12 points? All our 12 points. You read yourself first, then I will explain program. Understood at this point? This point? Tree set is used for storing objects in sorting order. The sorting order can be either ascending order or descending. The tree set doesn't have any. Understand? Tree set. Many people are saying tree set order is what? Ascending order, ascending order. Tell me. Already shown you the code. Tree set has any sorting order, calling comparative. What is doing? Tree set, it is comparing objects and storing in ascending, descending, or simply it is calling comparative method. It is calling comparative or calling what? Compare. Am I right? That means tree set has any default sorting order like ascending order or descending order? No. People are confusing. The natural sorting order of tree set is the adding object supplied sorting order in compare to and compare method. In compare to, in comparable dot compare to method. Okay, na? Very, very important point. Tree set doesn't have any default sorting order. People are saying the default sorting order of tree set is ascending order. Wrong. How tree set no ascending order? Okay, if you say ascending order, which property ascending order? Student number ascending, course wise ascending, fee wise ascending, height wise ascending. Okay, na? So it's a confusion. People have confusion. The natural sorting order of tree set is the adding object supplied sorting order in comparable dot compare to. Who is this fellow? For sorting object, internally tree set uses two interfaces, comparable and comparator. For supplying default sorting order along with adding object, we must use comparable interface. For supplying custom sorting order separately by other programmer with other class, other programmer with different class, we must use comparator interface. The tree set doesn't have any default sorting order. Internally, it stores objects based on the default sorting order provided by the adding objects class with the comparable interface or the custom sorting order logic provided with the comparator interface. Else, tree set throws what? Class cast exception. Okay? Compulsory the object you are adding to tree set either must come with a comparable interface compare to or with what? Comparator interface compare. If you don't provide both, we will get exception. This is the point I am trying to explain for last 1 hour. All people registered? Pakka? Look at the code. Add method. Tree set object I created call add method F3. Inside F3 array put method I have to go to tree. Tree map. Can you let's see? Can you understand or not? Find it. Okay. It is now they are hiding the logic somewhere else. We need to debug to find. Okay. I'll debug it and find out. Okay, now. Can please write this code little bit so that you will understand. Okay, read first these points, remaining point. It is a non-synchronized collection. It is a ordered or unordered? Ordered collection. Stores objects in sorting. So that it retrieves the objects in the same sorting order. Yes or no? In which order objects are stored? Retrieving time, same order it will come. Next, implement data structure, red, black tree, backed by tree map. Data structure is what? Red, black. There are different types of trees available. One of the tree is what? Red, black. Its capacity is 0, incremented by 1. Inside tree set, we can store only comparable homogeneous objects with unique and duplicates. We can store duplicates, but retrieving time, removing time, there is a problem. Okay, na? We can store duplicates also. How we store, I will show you. Note, if you want to store non-comparable objects, we must supply custom comparator. Otherwise, otherwise we will get class cast exception. Runtime error, class cast exception. Sorry, this one duplicate I am really removing. So some problem will come. Sorry, comparable homogeneous objects, comparable homogeneous unique objects. Duplicates also allowed, but some problem there I will show you. Null is not allowed. Single null is also not allowed. Single null is also not allowed. If you try to store, it leads to runtime error, null pointer exception. Why? Because how can I compare null with the object to decide its position? Objects are stored in sorting order, can also stored in insertion order, reverse insertion order. If we return fixed positive and negative number directly, generally it is meant for what? Storing sorting order. But we can also store in insertion order, reverse insertion order. I will show you that. Okay. Next, objects can be retrieved only in sequential order. In adding, searching, and removing operations, tree set internally uses comparable.compare2 method or comparator.compare method. Tree set class has 4 constructors: no parameter, collection parameter, sorted set, comparable set, comparator set. Okay. Okay. Can you please write these notes? Tree set sorting algorithm has 2 logics. Please write down these notes, then only you will understand. Is it visible? By projector. Online students, is it visible? So tomorrow, what time I can take your class? 9 a.m. okay? 9 a.m. 9 a.m. to 11 a.m. What class? Collections. Continuation. Okay? Collections continuation. 9 a.m. to 11 a.m. Okay, na? 2 hours. What? You man. Time okay na? Not okay? Your wish. If you want take, I'll take. If you don't want, I will not take. No problem. No force. If you want take rest, I'll give rest. No problem. Choice is yours. Ma? What? Arama. Aram means? Online students, okay na to everyone? Completed? Right on this one also. Tree set doesn't have default sorting order. Everybody saying ascending order is the default order. Wrong answer. Tree set default sorting order is not ascending order. Tree set sorting. Tree set sorts elements according to the natural sorting order given in adding object class comparable interface comparative method. So this is very important point to register in your brain. Tell me, whatever the logic you write in comparative method, according to objects are sorted. Just use your brain little bit. Suppose from comparative method, it return negative number. Object is stored left. From comparative method, if return positive number, object stored right. If return 0, object is not stored. Assume, listen carefully. From compare method, I return directly 5. And then what happened? Tell me. First object also return 5. For second object also 5. For third object also 5. For fourth object also 5. Always returns what? 5. 5 means what? Negative number or positive number? Positive number. Positive number means objects are stored which side? Right side. Then tell me, objects are storing in tree set in sorting order or insertion order? Insertion order. Sorting order. Insertion order. Why? Always you are returning what? Positive number. Positive number means what? Store, right? First object stored. Second object storing return positive, S2. Third object stored return positive, S3. Third, fourth object return positive, S4. So what is storing? Right. Right means what? Insertion order. Okay. Next. Suppose if I return -5, negative number. Now first object stored what? S2. Yes, sorry, S1. Now I am trying to store S2. Now tell me what return? -5. -5 into negative. Negative means which side? Left side. S2, S3, S2 left, S4, S3 left. Now left. This is insertion order or reverse insertion order? Reverse insertion. If return 0, then current object is not stored. Total in tree set class, how many objects available? Only one. All objects are considered as duplicate, even though they are not duplicate. This is the written test exam question. In written test exam, to test whether you clearly understand comparable, comparative method, comparator, compare method usage, they will not give you regular what you learn in your college, in your institute or even your training. They will give you this kind of hard-coded value. Then finally, you will be trapped. Understood? So be careful. So totally, in comparative method, we can place below 5 cases logic. If we place current object minus argument object, then objects are stored in ascending order. Argument object minus current object reverse, then what? Descending order. If written directly, positive number, insertion order, including duplicates. Negative number, reverse insertion order, including duplicates. 0, only first object is stored. Understood? Write on this case, and we will write program for understanding all these points. Program రాస్తే మీకు అర్థమవుతుంది. If I write a program, you will understand. This is a compulsory asking written test exam questions. Collection chapter written test exam questions. It's not only comparative method, compare also. Either comparative or compare, any of the two. Completed? Please write this code. We will try to understand with example. Please place them in box first like this. Completed up? Add this code. Whenever you see tree set, immediately what thought should come? Comparable interface must be implemented by the class A. We are adding which class object? A class object. A 1, 3, 1, 2, 4. And tell me, all these are preset class. Consider reference to compare? No. Consider data to compare? No. It's depending on the comparable interface. Internally, which method is called? Comparable. Comparable, comparative. Okay, write down. I will explain in system. First, you write this. As it is, I will also develop and I'll explain. Completed this one? Look at this A dot Java, how I have written. Write down. Compulsory this class must implement from comparable, else it leads to exception. Remember that. Tell me, because your class implementing from comparable interface, compulsory we must override compare to method, public in, compare to of, insert code here. Okay. Now I'll give the case 1, case 2, case 3. Then what is the output? You must guess and tell. Okay. Now let's see. You try to put your brain and tell me. Identify how many objects are added to tree set and which order. Right. This question. Case 1. Return directly 0 means inside comparative method here. Insert code here, place what you write? Return 0. If return 0, how many objects are stored? 0 means first object compare, second object compare, first object return 0. 0 means what? Duplicate. Stored or not stored? Not stored. Next, third object compared with the first object returns what? 0. 0 means not stored. So finally, how many objects available? Only one object. Which object? The first stored object. Okay. Sorting order, only first object, that is what? A of 1. First, I want you get into your brain, then I'll show in the system. Insert return 0 in comparative method. Again, I'm repeating. Add method takes decision to store or not by its own based on comparative return value. Comparative returns 0 means what? It's duplicate, don't store. So you have to remember that number. Okay. It is not having its own algorithm. It is just following comparative method given option. Storing order, only first object, output A of 1. Online students understood this case? Why only one object? Because 0 written. If completed, I'll show it in system. Completed? Look at C. Look at here, buddy. I'm creating reset object. Let me write same code instead of retyping again. This is our reset class code. Copy, paste. Okay. And this is our A class. You can write this class A in the same Java file or a different Java file, your wish. I'm creating in a same Java file for easy understanding. The next, insert code here. What I'm inserting? Return 0. Return 0. Tell me here, when I call ts.add, stored directly. Then second object, what is doing? It is calling A2. Assume that new A of 3 is called what? A2. A2 dot, what it is called internally? Compare to of A1. Then what it return? Compare to method in A2 class A returns what? 0. 0 means what? 0 means what? Duplicate. It's stored or not stored? Not stored. Finally, in the tree set, how many elements available? Only one, that is first object. A of 1. Okay, na? Next, case number 2. Case number 2. Commenting it, and I'm writing return 1. You can write 100, 200, any positive number. Any positive number. Positive number meaning is what? It returns what? 1. 1 means positive. Positive means unique or duplicate? Unique. Unique means which side should store? Right. Right side it is stored. Then A3 is compared with what? Compared with which object? A1. Returns what? 1. 1 means what? Right side. Right side already A2 is available now. Then again compared with the A2. A2 A3 compared with what? A2. First compare with A1, then compare with what? A2. Also returns what? 1. 1 means what? Right. Then A1, A2, A3. Then next, now I'm storing A4. A4 dot compare to of first object available what? A1. A1 compare. A1 found, A1 dot compare to method returns what? 1. 1 means what? Right side. Right side already A2 there. Compare with A2. Now returns what? 1. 1 means what? Right side. Right side already available what? A3. A3 compare final returns what? 1. 1 means what? Again it is right side. So A1, A2, A3, A4. Like that, A5 also stored right side. And now this duplicate stored or not stored? Come on, duplicate stored or not stored? You are using your brain. Don't use your brain. Stored or not stored? It is storing, not storing, depending on comparative method decision. Comparative method returning 0 na 1 na? 1. 1 means what? Store. That's what I'm saying. Don't use your brain, use the algorithm. So JVM add method doesn't use its brain. It is just asking comparative method. Or a comparative method, tell me, is it duplicate or not? Tell me, is it duplicate here? A of 1, duplicate or not? Yes. Then stored or not stored? Stored. That's what I'm saying. Don't use your brain. If you use your brain, you'll give wrong answer. Whenever you see add method, immediately you have to go to where? Comparative method. Whatever comparative method saying, accordingly you have to store. Look at that. Including duplicates. Objects are stored. Right side. Stored, right side stored, duplicate stored, right side stored, duplicate also stored. Why? Because you are returning what value? 1. You are comparing objects and taking decision, blindly taking decision, blindly. Then case number 3. What the case number 3? Return -1. -1 means, are you comparing object data directly saying unique? Directly saying 0 means duplicate. Negative number or positive number means unique. You are saying unique. Unique means it will store. Which side it is stored? Left side. Left side means what? Reverse insertion order. A4, A4, A2, A1, A3, A1. Understood? Right. Now, the 3 algorithms, whatever you have written here, are these project algorithms or they are interview algorithms? Interview. In project, will you store objects right side, right side, right side, insertion order? Tree set, if you want to store in insertion order, why you come to tree set? Go to array list. Yes or no? Tree set means what? Sorting. If you want to sort, compulsory you should compare current object X with argument object X. What is this algorithm? Current object minus argument object. When you compare current object minus argument object, objects are stored in ascending order. How ascending order? Let us compare. Everyone ready? How ascending order will come? Ascending order means right side, bigger object stored right side, smaller object stored left side. Okay, let's see now. First A1 directly stored. Okay, then next A3. A3 means what? A3 is become current object. Current object dot X, what value? 3 minus argument object, already available object 1. 3 minus 1 is what? Positive number. Positive number means right side. Okay, here what is the object available? A of 1, A of 1, A of 1. Okay, then it's a simple mathematical calculation. Please participate. Next, A of 1 already available in the collection. Now we are trying to store what? A of 3. A of 3 minus A of 1, positive. Positive means which side? Right side. A of 3. Okay, next, now I am calling A of 1. Bolo, A of 1 is compared with what? A of 1. Tell me, 1, current object A of 1. 1 minus 1 returns what? 0. 0 means duplicate. Stored or not stored? Not stored. Further comparison there or not there? Not there. It's ignored. Then next, now next object is what? A of 1. Now comparing A of 2 minus A of 1. Current object minus argument object. A of 2 minus A of 1. What is that? Positive. Positive means right side. Right side already one object is there. Then A of 2 is comparing with A of 3. 2 minus 3, negative. Negative means what? Left side. Move it. Okay. A of 2, comma, A of 3 moving. Understand? Left side, right side, it is rearranging. current object, adding object minus already available object from left to right, sequential order. I mean, linear searching comparison will done. Then next, A of 4. Tell me, by the time this add method is called, already in the collection, what object is available? First object, 1. How it is compared? According to compare to method logic, current object minus argument object. What is the current object? A5. A5 data is what? 4. 4 minus 1, positive. Positive means right side. Right side already we have what? One object 2. Again compare 4 minus 2. 4 minus 2 means what? Positive. Positive means compare with what? Right side object. Right side already one object is there. Then 4 minus 3. 4 minus 3, positive. Positive means what? Right side. देखो, objects are storing in ascending order or not? Next, now again you are calling A of 5. Then what it will do? It will compare. What comparative method is called? What is the logic written? Current object minus argument object. Adding object minus argument object. What is the adding object? 4. 4 minus 1. 4 minus 1. What the value? Positive. Right side. Right side already object available. 4 minus 2. Positive. Right side. Right side already object available. 4 minus 3. Positive. Right object. Right side already object available. 4 minus 4. 0. 0 means duplicate. Don't store. Understood? Control F11. Look at that. A 1, 2, 3, 4. Ascending order. Duplicates there or not there? Not there. అర్థమైందా? Everyone understand? Online students? Understood? Now I want you teach me the next algorithm. Case number 5. Write argument object minus current object. Okay, then what is this? Argument object minus current object. Then reverse. Reverse means what? Descending order. How the descending order? Tell me now. First object stored A of 1. Then next, what is coming? A of 3. Okay, it is comparing with current object available here. How the logic is comparing? Current object is 3, argument object is what? 1. What logic you have written the comparative method? Argument object minus current object. 1 minus 3, negative. Negative means what? Left side. A of 3. Understood? Then next, what is the first object available? A of 3. Tell me. Now I am storing A of 1. Then A of 1, what is the argument object? A of 3. 3 minus 1. 3 minus 1. Positive or negative? 2 or 4 or 5, I am not asking. Positive or negative? Positive. Positive means which side? Right side. Right side already object available. What is the object? A of 1. It's compared. 1 minus 1, negative. Sorry, 1 minus 1, 0. 0 means not stored. Duplicate stop na? Next. Now, next add method when you call, what the objects available in the collection? A of 3. What the logic? Argument object minus current object. What the argument? Collection object. What is the collection object data? 3. 3 minus 2? Positive. Positive means right side. Right side already object available. Again, 1 minus 2. 1 minus 2? Negative. Negative means left side. Left side it is stored. Okay, now? Look at that objects are storing ascending or descending? Descending. Then next. Now here, A of 3. Now we are storing A5. Comparative method called. What is the logic in comparative method? A dot x minus this dot x. A dot means what? Argument. Argument means collection object. A of 3. 3 minus 4. First one, negative one? Negative. Negative means what? Right side. Left side, sorry. Left side. A of 4. Remaining objects are as discussed. Only one comparison. No further discussion. Okay. Next. again called. What is the current object available? A of 4. Tell me. Now 4 minus 4 represents what? 0. 0 means duplicate. Duplicate means no further discussion, ignore. So this is how you have to work by using comparative method comparison. Written test exam, this will be the question. Okay. Now, totally how many cases? 5 cases. Among these 5 cases, first 3 cases are, they are just for interview, not for project. Among these 2 cases, which case is the general preferred case? Descending or ascending? Which is the preferred case in the real life? Ascending. Then who is the default sorting order we left? Ascending order. Okay, na? Ascending order is the generally we will leave the ascending order. Right, continuation. Everyone understand how to work? If you have doubts, confusion, ask. Online students understood, Babu? You have to work with your hands and brain calculation. Completed? Down, write down. Case 5, case 5. Case 5 also written? Nine a.m., buddy. 9 a.m. Completed? Write down the point. String class and in all wrapper classes in a string class, in all wrapper classes, comparative method is overridden for storing their objects in ascending order. For storing their objects in ascending order. And what the logic will be? It means the logic in the logic provided in string and wrapper classes is return current object minus argument object. It means S2 minus S1. Current object is always adding object. Argument object means adding object minus already added object. ఈ పాయింట్ బుర్రలో పెట్టుకోవాలి. Completed? Write a question. Develop a program to store. Develop a program to store string, comma, integer, string, comma, integer, comma, ex and sa classes, objects, in tree set. In tree set. Okay. Let's see this program, if you can understand or not. Look at here. Little difficulty if you don't use your brain. That's why tree set Aram says slowly explain. Look at there, I created tree set object with any comparator, no comparator. I am using no param constructor, no comparator. Then the objects are stored based on default sorting order given in adding object class. Given in adding object class in comparative method. ts1.add of double quotes here. Which object I am storing? String. First, inside add method, first it is verifying. Yeah, I'll give Nana, I'll give break. Wait. Okay, na? 2 minutes. Please give me 2 minutes, I'll give break. ts1.add of double quotes A. What is double quotes A? String. Now, when you are storing string, first step add method verify, is it comparable type or not? String is a comparable type, na? So no problem, stored. Okay, then next, ts1.add of double quotes C when I write. Now, what is called double quotes C dot comparative of already added object. That is the ascending order, na? Adding object minus argument object. Adding object ASCII number 97 minus 97. What is the number? Positive number. Positive number means right side. C, A already available, A right side, C. Then double quotes B. Now double quotes B is now storing, compare with the first object A, B minus A, positive or negative? B minus A, is it positive or negative? Entasepu, how much time you will take, buddy? B minus A, how much time you will take time to answer? Negative or positive? Positive. B minus A, positive. Positive means which side? Right side already C available. 98 minus 97, positive, right side. Right side already C available. Then what it will do? It will again compare B with right side available C. B minus C, positive or negative? Negative. Negative means left side of A na, left side of C na, left side of C. Then C move to right. Then what is stored? A, B, C. So output will be A comma B comma C. Understood? Tell me now. In tree set, can I store heterogeneous object 5? Possible or not possible? Can I store heterogeneous object TS1 dot add of 5? Allowed or not allowed? Not allowed. It leads to exception. What exception? Class cast exception. What is the first object you have stored? String. Then in this tree set, we can contain only strings. Class cast exception, integer cannot converted to string. Okay. Class cast exception. Okay, next. Now I am trying to store null. Can I store null? No. It leads to null pointer exception. It leads to null pointer exception. Why? You cannot compare null with other objects. It leads to null pointer exception. Control F. Null pointer exception. So what is the rule? If you want to store objects in tree set, it must be comparable homogeneous object. What is the first object you have stored? That only you can store. Other objects you cannot. If you try, it will throw error. Then next, tell me now. I am trying to store duplicate TS1 dot add of double quote say again I am storing. Tell me, if I try to store a duplicate, by default, what logic is implemented in collection? Ascending order. Current object minus argument object. It's not stored. Duplicate is not coming. Only we will get what? Only we get ABC. Okay, A is not stored. Duplicates are not allowed. Okay, is it clear up to now? Tell me. Now, integer objects I want to store. Same flow. Integer also have the comparative method implemented with what logic? Comparing. Which comparison? Ascending order comparison. Ascending order comparison means what? Current object minus already available object. 5 already available? No. 5 stored directly. 7 minus 5 positive, right? 5 comma 7. 6 minus 5 positive, right side 7 there. 6 minus 7 negative, then left side. So what is output get? 5, 6, 7. Okay, everyone understood? This is what the way you have to practice. Okay, now? Now, if you have patience to continue, or let me stop. Because comparator, another way of comparator implementation I have to explain. For that, I need 45 minutes time. Tomorrow, if you have, okay, sir, enough. Let me practice this. Tomorrow we will discuss, and tomorrow we will discuss. Already 2 hours completed, that's why. 8:05 to 10:05. With break, you can continue, or tomorrow we'll continue. Anything okay, take decision based on your mind capacity. Tomorrow? Yeah, many people are saying tomorrow. Okay, let's take tomorrow. But tomorrow when you're coming, you have to type this code in your system, practice and come. If you come tomorrow without practicing, tomorrow class, you cannot understand. Okay, na? Right. So thank you. That's all for today class. See you tomorrow. Tomorrow class timing is 9 AM, not 8 AM. Okay? 9 AM to 11 AM. Or if required some extra, or more half an hour, I'll take. So let's keep it as 9 to 12. Online, no offline. On Sunday only on. So 9 to 12, 3 hours. In middle, I'll give one small break. Tomorrow class easily you can understand. This is only the complex topic of entire collection. Okay, now online students? Let me make it the class as 9 to 12. Multi-threading we will postpone, no problem. Let me first complete this collection talk. Chalo. Thank you. That's all for today class. I'll upload up to the discussion. Everyone please go to room and practice now only. Okay, now don't postpone. Thank you.